Hello, hello. So in this video, I'm going to show you how to get some R code for week 5, our lab for week 5, and how to run a correlation and a partial correlation. So one thing I wanted to mention, the course content, this was buried in an email somewhere, but I want to be more clear about it. We're going to use the homepage. Don't use the modules for course content. All of the updated content is going to be on the homepage. The modules were a leftover from how I was going to design the course, but we're not going to be using that. We're going to be using this. This is where all the information is going to be. And going forward, those modules won't be there. I tried to delete them, but I couldn't really figure out how to delete them without having to change everything. So that's why they're still there, but this will have all of the information that you need. So you'll click on the home page. You'll click on, for this week, week 5. And then I have some information, a little video about correlations. This is what we're learning this week. The book has more information, but here I'm just kind of getting your, it's a little brain teaser, I guess, or a little brain appetizer for the course for this week. So you'll read the book, chapter 7, and you'll follow along with the PowerPoint, and then you'll take your mastery quiz. And then you'll download this R code, and this is where your material, a lot of your material for the lab is going to come from here. It doesn't always come from the practice R code. Sometimes it comes from the book. But if I'm asking you to run some R code, it's usually coming from these practice R code things that I provide for you all. So you'll download the R code, and to open it, I think I've mentioned this before, but to open it, you'll show in Finder and open with RStudio. Okay, awesome. So it should look like this. You should have your 4 panes, and it shouldn't be in just regular R, it should be in RStudio specifically. So then I have these comments that are explaining what's going on with our data file. So for this example, we're going to be uploading this chapter 7 data set. So this is just some little practice data set that the book provided you. I also had it on, where is it? On this homepage. So you'll download this data file, download, and then you can import it into R using this code. So we'll click on the code, we'll hit run, and because I just downloaded it and I didn't have it saved somewhere, it should be just in my download file. So I'll just start typing it in to find it. No, something, oh yeah, no R. Okay, so there it is. And you'll have to notice whether or not it's in a CSV file. It has to be in a CSV file. If you find that it's not in a CSV file, then you can find wherever you put your file, right? Open it up. And then save as, and change the file format. Make sure it's a CSV. In this case it is, but I have noticed with some people with their, maybe with their PCs, I'm not sure, but it'll come up as an Excel file instead, and then you'll get an error. So you'll just save it as a CSV file, Maybe you'll save it into your class folder if you want to make it easier on yourself. But in any case, it's a CSV file and it's there waiting for you to be imported. So now that we have our data file as a CSV file and ready to go, we'll click on it and make sure you're clicking on the right one. Make sure it looks like what the file looks like. Sometimes there's things that maybe seem like they're the file, but they're not. I've seen that on some people's computers where it was like a, I don't know, it wasn't a CSV file, it was like a web page or something. Just make sure it's a CSV file. You have the rows, the columns that have our data in it, and you'll hit open. Now, you didn't see anything over here because I'm searching for something in the environment pane, but what you will see in your own is the file will come up. Then you can click on it and you have your two variables. There's 20 people and you have income and education for each of them. You can do the same thing by running this. It'll show you the exact same thing. If there's something that goes wrong here during this phase, email me and let's talk about it. We can set up a time. Email me just through your regular email instead of through Canvas. Okay, so now we are going to calculate a correlation between income and education. So to calculate a correlation, we just use this little tiny core function. That's all it is. You just say core. And then you have to tell it what you're correlating. You're correlating your X, that's what that all says, and your Y. So whatever your X is, comma, Y. Now let's break this down a little bit. What we're telling R here is we want to correlate income, but notice, if we just type in income and education without all this goop over here, you're not going to get what you want. You're going to get an error, right? It says education not found. It's angry with something we're telling it to do. And the reason why is because in R, you may have multiple data sets going at one point in time. For instance, if I show you what I have in my environment pane, because I have several different research projects with different data sets, and I also have our data sets from class and stuff, then there are a large number of data sets I could be asking R to calculate or to perform a function on. Could be extroversion, could be ice cream, it could be these nodes, any of these things. But we want it to be specific to income in this Chapter 7 DS1 data frame. So in order to do that, we need to tell R to look in the Chapter 7 DS1 data frame and find the income variable. So anytime we're working with a data set and we're performing a function on some variable within the data set, we always have to tell it first what data set we want it to look in, and then what variable within that data set. And then we have to do the same thing for education, because if we just have this, it won't know where to look. We need to tell it to look in the Chapter 7 data set to find the variable education. So, and if we wanted to do it on a different data set for our lab, for instance, I think we're doing social for the lab, right? Then we will type in a different data set and tell it, and see, look, it already can tell what variables you have in that data set. So then we'll tell it what variable we want to correlate. Okay. So we said, look in Chapter 7 data set, find income, and correlate that with look in Chapter 7 data set, find education. Then we click on this line. You can click anywhere on this line, but it has to be on that line, and hit run. And it should tell you the correlation down here. Now, we're always going to round to the second decimal point in this class. So if we were writing our correlation for our lab, we'll look to the third number in the decimal point. If it's less than 5, we keep it as is. So here it would be 0.57. But if it was 5 or greater, we would round up and it would be 0.58. And that's APA style that is commonly used in the social sciences. Okay, awesome. So that's how you do a correlation. Now, I also ask you guys to do a scatter plot. And what do you know? Here in this practice R code, I have some examples of how to calculate a scatter plot between these two variables. So first, let's just run the basic scatter plot. And again, we're actually using the same format as we did for correlation because we want to know the plot between two variables. So variable 1, comma, variable 2. And we have to do that same naming convention of look in chapter 7, find income. Look in chapter 7, find education. So we hit run, and then we see this little scatter plot over here, which is kind of cool because you can kind of see already there's a positive relationship between the two. They look like they kind of tend to rise and fall together. But it's ugly, right? We don't have a name down here. We don't have a name for the graph. This isn't, I mean, we do have names, but they're really ugly looking. It would be super confusing if you were showing this to a person who wasn't working with this data set. So we're going to add a name and for the main graph and X label and Y label. This is the same as what we did before when we were dealing with graphs. It's the same thing. So we tell it to correlate X or to plot X with Y. Then we just tack on this little additional function here that names it's the main title. Then we give it a Y label, number of years of education, and an X label. And again, we should be able to just click on it and then run it, and it'll run those whole 2 lines of code. And it just does the same thing, but it makes it a little cleaner, a little nicer. So that will be something you'll see on your lab. Now, there's also this thing called a partial correlation, which we talked about, or we read about in our book. A partial correlation is essentially, it allows us to look at the correlation between X and Y while removing the influence of a third variable, Z, from both X and Y. So in your book, there's this description of how ice cream consumption is correlated with the crime rate. And we wouldn't expect to see that, right? Why, if it's not like consuming more ice cream is causing more murders or something, right? Like you're just going to Jenny's and waiting in line, and because you had to wait in line for so long, then you just, go into this murderous rampage or something, right? Like that doesn't make sense. So the most likely explanation for this is that there's a third variable that is increasing or that is positively related to both crime and ice cream consumption. And that third variable in this case is likely average temperature. So as the temperature increases, people are probably going to go buy more ice cream. You don't really want a bunch of ice cream, when it's cold and snowy and gray out. Maybe some people do, but in general, people want more ice cream when it's hot out. But at the same time, as the temperature increases, people have less self-control, right? They're kind of cranky because it's so hot. And maybe that tends to increase crime. Also, more people are walking around outside. Maybe people have their windows open. There's probably more opportunities for crime if it's warm out as well. So the idea here is maybe the positive relationship between ice cream consumption and the crime rate is not actually due to a true relationship between these two things. It's actually due to average temperature that is increasing the crime rate and increasing ice cream consumption. So that's our thought. But we can look at this thought empirically. We can test it essentially. We can see, okay, let's use a partial correlation to take out the effect of average temperature in this whole little equation. And we can look at the relationship between crime rate and ice cream consumption without the influence of the average temperature, this third variable. So for this little example, I'm going to make a data frame. And this is just for information purposes so that you guys don't have to go and download another data set. So I'm going to make my vectors. These are our variables, right? Same way we've been doing it with our caret and our C and then the list of values. And I'm just going to run it for all three at the same time. And you see it down there. You have our vector. There's the other one. Sorry, this is ugly. Okay, now I'm going to just merge them all together using this data frame function. So I'm going to name a new object called ice cream. I'm going to use the function data frame, and using data frame I can merge ice cream consumption, crime rate, and average temperature. Now you don't need to do this if you are downloading a data set from outside, right? So here we just downloaded our data set and that's how we got our variables. Right now we're making our variables, but again, this is not what you'll have to do for your lab. This is just for illustration purposes. Okay, so I make our data frame and you can see it over here. I'm going to click on it to look at it to make sure it looks good. Yep, looks fine. Now, I have a little blurb about how to install packages and then how to activate them. You'll have to do that to use this pcore function. So pcore, this is the function we're using for a partial correlation, is part of this ppcore library or our ppcore package. To use this, this has to be activated. So I searched for it already. You can just see if it's activated by searching for the name of the package under this packages pane. Make sure it's ticked. If it's not ticked, you'll see what will happen. There's an error, right? It says, could not find this function. It's angry. So you can activate it, as I mentioned in the other video, this way, and then you see it's ticked, or you can just tick it yourself, whichever. All right, now for the pcore function, it takes the argument slightly differently. For correlation and for most of the functions that we've used so far, plot included, it takes these vectors, right? That's the specific type of object in R that plot takes. pcore is a little different. It takes a data frame. So you'll notice that instead of doing something like ice cream consumption, instead of naming the data frame, right, and then adding in the vector, we can just put in the whole data frame. Because, why? Because we're trying to find the partial correlation between all of the variables in this data frame. What we really want is the partial correlation between ice cream consumption and crime rate while removing average temperature. But because we're interested in all three variables, we'll just plop the whole data frame in there. So I run it, and then there's a lot of stuff down here that R gives you. It's a little confusing. What is happening? Sometimes it comes, that's what you get, is something that looks a little intimidating. But if you just stop and you break it down, you can kind of piece it all together. So, but I'm going to show you, and I gave a little description here too. to explain what we're looking at. So our function worked. And then we have this thing called estimate. An estimate is the partial correlation. Now, it's given to you in the form of a matrix. So we see the partial correlation between all of these variables. If we look at ice cream consumption and then we cross it over with crime rate, this gives us the partial correlation between ice cream consumption and crime rate while removing this other variable, average temperature. So actually, this is sort of surprising, right? Because we thought, well, why would ice cream consumption be related to crime rate if not for shared positive relationship with average temperature? There's no reason these two things should co-occur together other than the temperature increasing. But actually what we see is ice cream consumption is positively correlated with crime rate at 0.23, which we round up because of this 5. So that's interesting. That actually challenges our assumptions that we made beforehand. So we had these assumptions and then we got some data and we could see if those assumptions were true. Now, this is fake data, so that this doesn't really give us actual information about these relationships. I would guess it's probably 0 or close to 0 in real life. But the point is, you can use partial correlation to examine the relationship between two things while taking out a third confounding variable, like average temperature. So this is what we're interested in. For our lab, we're going to look at that. It gives you additional information that you don't need for the lab, but if you were doing a research project, maybe would be important or would be interesting. It also gives you a p-value, which we don't know about yet, but we'll talk about that later. And then I don't even know what that is, but there's all these other things that we don't need. The main thing is we want the estimate. So that's how you calculate a correlation, how you calculate a partial correlation. You're going to use essentially this same R code and import it into a new R script file for your lab. So for the lab, you will, first you'll have that hand by hand part that you calculate a correlation by hand. Then you'll do task 2 and task 3, say I have an example there, in R. And then you'll copy the R code into your file that you upload. And you'll do that by making your own little R script. So task 2, and then you'll write your little code there to answer the questions. And then you'll include your text answer as well. If I ask you to describe something or to explain what something means, that'll just go in that text file and then or text portion, and then you'll copy the rest for the R code portion. And you'll save it, and then when you're done with all your R code, you'll just copy this and paste it into the data file. Okay, so that is how you calculate correlations, how you find the R code, and how you can turn it in for your lab. If you have any questions, or you have any problems at all, send me an email. Send me an email directly instead of through Canvas, and we can talk about it one-on-one.